Hi, my name is Dana Golden. Today we're going to talk about cross-validation. Cross-validation is really important in machine learning because you need to check multiple parameters to figure out which one works best. So there are a couple ways to do cross-validation. One way is to split your data set into train, test, and cross-validation data set. Another way, as we're going to do here, is what's called k-fold cross-validation, where you train your model on a subset of your data, and you leave out some, and then you do that across each of the folds of the cross-validation. So we'll load the iris data, x equals x dot iris dot data, y equals iris dot target. Let's see what this looks like. Here's our data. This is some data on plants, and then we're classifying them based on which type of plant they are. So we do train test split. We test size equals 0.2, random state equals 42. We initialize our k-fold cross-validation. We create our model of logistic regression. We run our model, and we get scores for each of the folds. So on one fold is perfectly accurate, on another fold is perfectly accurate, and then on the other folds it's less accurate. So this is k-fold cross-validation, which if you want to visualize it, it's basically think about it as we're using this first fold as test, everything else is train, then the second fold is test, and everything else is train. And then we just keep going throughout that. Then we have leave one out cross-validation, where we're leaving out one element of the data set for prediction, and we're doing that throughout the entire data set. So we're getting the scores. This one takes a little bit longer. It's really just another form of k-fold cross-validation with a really small portion of the subset, the data set left out. So the scores, some of them are perfectly accurate, some of them are inaccurate, but overall the average accuracy is 0.97 plus or minus 0.18, and then we can do stratified k-fold. So this allows you to test across different models to see how well the model performs on different levels. This is extremely important when you're using different parameters for your model and you're trying to figure out which one works, but you don't want to test on the test asset. Why you don't want to test on the test asset, but you instead want to test on the cross-validation data set is because if you're testing on the test data set, you will end up biasing your data. So here we have this California housing data set. So we are doing mean squared error because this is no longer a classification data set. So we just do data. You can see here we're regressing the price on all these different features. We get the target data. We create a model, linear regression model, do k-fold cross-validation, and we get the scores for each of the folds. And then we plot the scores by fold. Recall that lower MSE means that it performs better. And then now, let's say we were doing a ridge regression and we're choosing between a set of different alphas, alpha being a strength of regularization. Here we find out that an alpha slightly over 10 to the first works better. So notice you're comparing all the different alphas and you're choosing the lowest one as the one to put in your model. So here we're going to do a breast cancer data set that predicts whether or not someone has breast cancer. We're again going to do k-fold cross-validation. And we end up with different average accuracies by fold, which we can use if we want to choose between models by choosing the model that has the highest accuracy for all folds based on the parameters. Yes, that was cross-validation. I hope you have a great day.